Hello, my name is Casey Shibler and I'm doing a reassessment video on the electric potential standard. For the last video I sent you, I did two spheres, so I decided to do something a little different, finding the electric potential from a dipole. So basically the problem says a dipole is centered at the origin with its axis along the y-axis, as you can see. Oop, maybe not, right here. So that at locations on the y-axis, the electric field due to the dipole is denoted by this. We have 0, 1 over 4 pi epsilon naught, 2qs, q being the charge, s being the distance of the charges on the dipole, and y, in this case, y is kind of like r, where it's asking to find the distance from the dipole to the observation location. 0 in the z-axis, volts per meter. So it says the charge making up the dipole, or the charges making up the dipole, are positive 3 Newton coulombs and negative 3 Newton coulombs, and the dipole separation is 2 millimeters, so that's S. What is the potential difference along the path starting at the location 0 to 0.03, 0 meters, and ending at the location at 0.04 in the y direction? So what I have done is I have to basically find the potential difference. So I know that the potential difference is equal to negative the integral of E dot dl. What I did is I broke it up into parts. Since it gave me the electric field at the y component, I just plugged it in here. I know this is 0, I know this is 0, and I know this is going to actually have a value. So I went ahead and put it in here, and so I have to integrate this. The 1 over 4 pi epsilon naught is going to stay the same, so that's constant, and so is the 2qs, because the s is not changing between the dipole, and the q is a constant 3 nanocoulombs, and 2 is just, well, it's 2. So I pulled those out, so I'm left with 1 over y third, the fraction, dy minus, 0 minus that, minus 0. So what I did is I went ahead and integrated. That gives me 1 over negative 2y squared. My negative 2's will cancel, so that will leave me with qs over 4 pi epsilon naught, and now this is positive because my negatives canceled out, 1 over y squared, and which I'm going to have to integrate from 0.03 to 0.04. So whenever I plug these values in over here, I'm going to get negative 486.111111. You know the deal. And then I will go ahead and plug in my values into my new equation. So I have 9 times 10 to the 9th, which is 1 over 4 pi epsilon naught. That's what that equals. 3 times 10 to the negative 9th, which is my q, which is from, well, I guess I don't have it written down. Q is my charge of my dipole. And then I have 0.002 meters, which is my S, from 2 millimeters, times my new value that I solved for over here, negative 486.11111111, which is my y value now. And that gives me a total potential of negative 26.24999999 volts. And this is, I believe, and yeah, it's an even problem. I set everything up correctly, and I have full confidence that I did my math right, because the math is actually pretty easy once you figure out what you're supposed to use for your values. So, enjoy. Thank you very much.